Today's focus is going to be semantic segmentation, which is a deep learning technique that is going to associate a label or category with each pixel in the image. So if indirectly we want to say, then we can say that it is going to be a kind of process or the task of clustering the parts of an image together, which belongs to the common object class. So it's a kind of pixel level prediction because each pixel in the image is supposed to be classified according to a category, and the different sorts of benchmarks have been used, and people have proposed the different sorts of methods for this particular thing in their respective research works. So we can go and have a corresponding exploration of the respective research works. But coming on to the basic implementation, so we have jumped onto this GitHub page where we are going to have the semantic segmentation PyTorch implementation. And this implementation is going to talk about some of the related things. For example, that this implementation is based on the MIT AD20K scene parsing dataset, and this dataset is the largest open source dataset for semantic segmentation and scene parsing. And obviously, this is released by MIT under the computer vision team. So there, if you go, then you can have the related demos. You can have the kind of implementation on Cafe and Torch 7. Then you are going to have the pre-trained models also, and you can use them. Finally, some of the related updates and highlights have been provided. And coming on to the specific role of semantic segmentation, then let me tell you that there are so many existing data sets have been used for this particular technique, and some of the related benchmarks have also been set up. So some of the common data sets that have been used include the Cityscapes, the NYU depth version 2, then Pascal context, and the dense pass, and specifically coming onto the details of the libraries, then people have used the pedal seg. People have also used the PyTorch image model. So coming to these sort of different sorts of data sets as well as their respective models, you are going to have some of the related key implementation at Google Scholar. You can go there and you can find some of the related papers. Most of them are the obviously implementation based papers because there you are going to download some of the related data set and then you are going to use some of the related model. And coming on to the specific detailing, then I'm going to quote just two or three works. So one work is MM detection, where the open MM lab detection toolbox and benchmarks have been used. It is also a PyTorch implementation. And the other one is mobile net version 2, where the inverted residuals and nonlinear bottlenecks have been discussed, which is the TensorFlow implementation. And it is discussed in CPR 2018. So CPR is one of the most reputed computer vision conferences. So there you can find the very good papers and you can have the related highlights. Coming forward, you can have the SegNet, a deep convolutional encoder decoder architecture for image segmentation. And obviously this highlights the pedal seg. And the swim transformer, the hierarchical vision transformer using the shifted windows have been discussed in ICCB 2021. So it's a recent paper, and ICCB again a top-notch conference. So all these things are some of the related examples. There are number of papers which you can go and have a look onto, and then you will have the basic idea that what you can do with these sort of papers or what you can gain from these papers, because so many related highlights and the insights that have been detailed in these papers. So coming to the semantic segmentation implementation part, so this particular thing means this PyTorch implementation is going to help you a lot because they are going to detail the supported models with respect to encoders and decoders. They have given the details. Then the performance of the different architectures based on multiple factors like multiple scaling testing, mean IUU, pixel accuracy, overall score, they have given. And when the environment is considered, then you can see means the environment is very important because many times we do see that we don't have the sufficient hardware to run a particular kind of algorithm or to run a particular technique onto our system. And many times, even if your system is bit downgraded in terms of architecture, then the performance goes low. Means it is taking more time or it is not getting trained properly, something like this. So you need to see the software as well as the hardware requirements, and you need to see the dependencies, the required libraries, which are very much important for the actual implementation of that particular work. are the essential prerequisites that you are supposed to install first. Moving forward, the quick start guidelines are given over there that to test on image using a trained model, you need to do this, for example, changing the mode and then running the shell script. Then going to the training part, there again, you are going to change the things. Then you are going to run a shell script, etc., etc. Multiple commands are given over here. Finally, the evaluation part is over there where you can evaluate different models. Finally, the integration with other projects is also given over there, and some of the key references are provided. So almost everything is available at this particular Git page, and whatever is available, you can go to CCL Vision page, means their Git page, and there you will find the semantic segmentation PyTorch implementation. It's a public repository. So I think there is no issue in accessing and doing all sort of experiments that you want to perform onto this particular uh, project. So that's all from my side for this particular video. Hope you must have liked some of the related things. If you didn't like, please do comment below and criticize the video. And let me know that what are the some more important research or research related things that we can incorporate in our videos. Thanks for watching. Have a lovely